Problem 1217, minimum cost to move chips to the same position. So what is the problem telling us? We have n chips where the position of the ith chip is position of I within the array position. And we need to move all the chips to the same position. And in one step, we can change the position of the ith chip from position I to position I plus 2 or position I minus 2 with cost 0, and position I plus 1 or position I minus 1 with cost is equal to 1, and return the minimum cost needed to move all chips to the same position. First of all, let's make sense of the cost criteria. Position I plus 2 or position I minus 2 with cost 0. How do you translate that? Well, let's say we're on position 2. What is 2 plus 2, 4? What is 4 plus 2, 6, etc.? And what about the opposite way? 0, negative 2, etc. What do all of these values have in common? Well, they're all even. So what this basically is telling us is since from 2 to 4 is 0 and from 4 to 6 is 0, and that means 2 to 6 is also 0. In other words, if you extrapolate this, moving any coin from an even position to another even position will be 0. And the same can be said for odd. Right, for the same logic, 1 to 3 to 5, and then to minus 1, and then to minus 3, etc. So from an odd to an odd, it will also be 0. It's only when we go from an even to an odd, or vice versa, that we have a charged cost of 1. So what this effectively means for our problem is that if we, for example, had 3 coins on position 2, and we had 4 coins on position 4, it is the same thing as just having, all 7 coins at position 6, all 7 coins at position 8, all 7 coins at position 2, right? Because there's no cost to move any of these coins. Therefore, all of the coins at all even positions can be consolidated into one big column. And where that column is doesn't matter to us. All that matters is we can consolidate all of them. And the same goes for even. So what happens is, let's say this is an even number and this is an odd number. We ultimately have 2 big columns in the end. And once we have these 2 big columns, we just need to move one column to the other to finish the problem. But which column do we move? Well, obviously, we should move the column with the fewest number of coins. That way, we minimize the cost, since moving each coin from here on out is going to be 1. So basically, we're going to, for every single coin in each position, if it is odd, we keep track in an odd counter. So this is in position 1, which is odd, so that's tally of 1. And 2, well, position 2 is even, so put a tally of 1. And the coin at position 3 is also odd, so give another tally to odd. So we have 2 coins in an odd position, whatever that may be, 1, 3, 5, doesn't matter. And another stack of coins on an even number, 2, 4, 6, 8, doesn't matter. We then have to basically move basically whatever odd number and even number to be the adjacent odd and even, but again, that's implied. And we basically move the one with the fewest coins, which in our case is the even stack. Therefore, we get the answer of 1. If this were, for example, 16 and 8, then our answer will be 8. So with that, we can program it up in Python. So as we said, we are going to iterate through every single position in the position array. And we're going to keep track of a counter called odd and an even called even. And if the position of the coin is even, then we increment the even counter. If it's odd, we increment the odd counter. So very simply, if p remainder of 2 is equal to 0, then we increment e by 1. Else, we increment the odd by 1. And that's it. We have officially counted all coins at the even and odd positions, respectively. Now we have to return whichever tower is the minimum. So return the min of O and E. And with that, we can just press run, and this should work, which it does, so let's submit. And with that, that's the solution.